Hello everyone. In today's video, I will be discussing the 2-4 notes in which we talk about how to write equations based on given transformations. So first I have a quick warm-up here to kind of help us get back in the groove of working with transformations before we go the opposite direction. So we have 5 equations here, and all we need to do is go through and identify what the transformations are and the vertex of the equation. So with number 1, we have an absolute value function here. And we know that there are 2 transformations because the original, if you remember, is just y equals absolute value of x. So we have 2 changes here. We have the plus 1 and the minus 3. So x plus 1, remember, this is where we do the opposite of what it says. So when we see plus 1, we originally think it's right 1, but actually it's left 1. And then we have the minus 3. You read it exactly as it says. That means down 3. And then our vertex, I'll just write it as a V. It's our transformation. So left 1 is a negative 1, and down 3 is a negative 3. So negative 1, negative 3 is our transformation, is our vertex. Number 2, we have a cubic function here. So it was originally y equals x cubed. And we have 2 changes here. We have the 1/2. Remember, the 1/2 in front means it's either going to stretch or compress. And if you remember, a number smaller than 1 is a compression. So this is a compression. And it's by 1/2 of 1/2. And then we have the minus 9, which again just means down 9. For our vertex, we're not given a left or right transformation like we were in number 1. So I'll show you with a post-it note how this would look. Or actually, I do have room down here. So if I write this out fully, this equation, it's the same thing as 1/2 x plus 0 cubed minus 9. So since we don't have a left or right transformation, it's just a 0 for our x value, for our h value, and then negative 9 like usual. So the point being, if there's no transformation inside with x, then you treat that as a 0. Number 3, we have a square root function. Y equals square root x is the parent function. And then our function has 2 changes here. We have a 3 in front. 3 in front means we're going to stretch or compress. This time our number is bigger than 1, so we are going to stretch. And then, of course, it's by a factor of 3. And then we have the x minus 5. Reminder, we do the opposite of what it looks like. So this looks like a left 5. This is actually a right 5. And so that's going to be a positive movement. So just a reminder of that. And then for our vertex, well, our h is positive 5, not negative 5. And then we don't have a k on the outside. That's the same thing as plus 0. So since we don't have a k, that's just going to be 0. 2 more. Y equals negative x squared plus 4. Here we have a quadratic function, y equals x squared. And we have 2 transformations here. That negative in front is a reflection. And reminder, that's over the x-axis. Be careful with this one. A lot of you on the quiz, we didn't have a negative in front, but you were still using reflection. Reflection only happens when we have that negative in front. And then we have a plus 4, which just means up 4. Again, we don't have any left or right transformation inside with the x, so we treat that h value as just a 0. And then our k here is a positive 4, 0, 4. Again, if I write that out fully with the parentheses, you'll see what I mean. That's the same thing as just x plus 0 squared, so we don't write the plus 0. So it's a 0. One more. Y equals a negative 5 times x minus 7 squared minus 8. Here we have another quadratic, so it's like y equals x squared. That was the parent function. Here we have 3 transformations. We have negative 5. Actually, let me take these. We actually have 4 transformations. First, we have the negative, which means reflection. And again, that's over the x-axis. So that's where the negative comes from. And then the 5 is a stretch. And then you'll notice down here, as we get to more problems, we just write it as a stretch of whatever the number is, so we just write stretch 5 there. So that was 2 and 1 transformations. Here we have x minus 7. Again, you do the opposite of what it says. So if that says minus 7, you treat it as a plus 7. So that's right 7. Again, that's a positive movement. And then minus 8 all by itself, we go down 8. Again, that's a negative movement, and these two numbers make our vertex. So our vertex V is positive 7, negative 8. Right 7, down 8 is how you would interpret that. All right, here we have several examples. We're basically taking our given transformations and making equations out of them, and we're doing it with all the different types of equations we've discussed in this unit. Mostly for time, but also to make sure you guys are able to practice. I'm only going to do the left side, so that will be the odds in all of these sections, leaving the evens for you to do by yourself, and I will have the full version posted separately for you to view and see if you did it correctly. So please try these on your own before you view that. That will really make sure that you're prepared going into the homework. And reminder, we have have a test coming up on this as well, so obviously you do have to know how to do this. So for this set, we are writing the equation with the following transformations using the general function y equals a times x minus h plus k. And this is in the absolute value function. So basically, this is what our equation is going to look like. We may not have an a, it just depends. We may not have an h, and we may not have a k. Depends on what it is. So compressed by a half, that tells us that a equals 1/2 because it goes in front. That's where the a is. Shift right 5, left or right, that's an h movement. So right 5 means that h equals 5. And then up 3, that's a k movement. That means k equals 3. Now you want to be extra careful here. I'll show you why. So we're going to plug all these in and see what happens. Y equals a is 1/2. Absolute value, x minus h is 5, plus k is 3. Hopefully now, if you didn't understand it before, you fully realize why we do the opposite here. Because when I plug h into its spot, I didn't do anything wrong. H is 5, so when I put 5 in there, now it looks like a negative 5, but it's actually a positive 5. That's why we say you have to mentally change this in your head. You think if this is positive 5, it does move right 5. This is how it's supposed to look. Stretch 3, again, that's in, oh, I started to do that. That one's on your own. It almost worked ahead too far. I'll leave that one for you. Number 9, reflection, that's where we have a negative. So that means we're going to have a negative a. And then translates right 1. Just another way to say shifts. Right 1. Right 1 is a plus 1 movement. So h is 1. Just 1. Down 3. K. K is up or down, is a minus 3. And again, we're using this equation here. Now we're working with a quadratic. Going to carefully plug these in. Y equals negative a x minus h is 1 squared, and then plus k is negative 3. So I'm going to rewrite this because this isn't fully how you do it. They didn't give me a number for a. So if they don't give you a number specifically for a, we treat a as a 1. So I'm going to write this as just negative. Now you could write negative 1 in front if you want. You don't have to. If you just have a negative in front, we understand that to actually be negative 1. So if they don't give you an actual number for a, you can drop it. But keep the negative there. That means reflection. X minus 1 squared, again, it's actually a positive 1, but when you put it in, it changes to a negative because of that minus. Plus negative 3, I can rewrite that. It's just minus 3. We understand that it's the same thing. And I'm done here. One more, or two more. I'm noticing that with these first two, I'm only doing the ones that move you to the right, and the others move you to the left. I want to make sure I do one of those. So for this next section, I'm actually going to do number 12. You'll do number 11 by yourself. This time our function is y equals a times x minus h cubed plus k. reflected, again, that's a negative a, and compress 1/3. That means a equals 1/3. So putting all of this together, a is actually negative 1/3. A equals negative 1/3. So we know it's negative and we know it's 1/3. So negative 1/3 is the full value of a. Shift left 2. Again, that's an H movement. H equals left is a negative movement, so negative 2. Now I'm going to put this over here. Thank God I have that extra space because I was about to run out. Y equals A, we now know is negative 1/3. It's a negative and it's 1/3. Times X. Remember, that minus is always there, regardless of what comes next. H is negative 2. I'm going to write that negative 2 in there. So we have minus negative 2. Parentheses cubed. There is no K. Which thing? Again, thankfully there's not a K because I don't have room to write it. Okay. We're not going to leave it like that. Let's simplify it a little bit more. X minus negative 2. These two negatives in a row become a plus. So now we have x plus 2 cubed. And that is my full equation. Again, there's no K given, so we don't write one. This is why when it's a negative, it looks like a positive. Because when you put that negative in there, these two minuses become a positive. So that's why you have to change what you're looking at in your head. So when you see this, you're like, okay, I see that it's a plus 2, but I'm actually going to think of it as a minus 2. So it's moving left 2, not right 2. All right, move it to the last one. Y equals a times the square root of x minus h plus k. I'll just do number 13. Stretch of 3 over 2. Stretch or compress, that means it's a 3 over 2. Shift right 5, so that's going to be h, and h is just a positive 5 since right is a positive movement. Down 3, that means k is going to be negative 3. It's moving down 3. Let's put it all together. Y equals a is 3/2. Square root. X minus h is 5. And then k is minus 3. I'll go ahead and just write it as minus 3. You can put plus negative 3 if you want. That means the same thing. There's nothing to simplify here. This is my full equation. No signs to deal with. I am done. Again, try 10, 11, and 14 on your own. I will complete the rest of this and then upload it so you can make sure you know how to do it. All right, we're going to step it up a little bit more. Given the graph, write the equation of the function. So we have to just, based on the graph alone, figure out what's going on with this graph. So first things first, you want to look at this and just ask yourself, what type of function is this? This U shape should tell you that it's a quadratic. Meaning is y equals x squared. So from here, I'm going to set up the general form of that equation. That comes from the page we were just on. So that would be this one here. I'm going to write out all those letters, and then I'm going to figure out what goes where. Y equals a times x minus h squared plus k. This is all the information we have to find to fully create our equation. Again, some of this information we might not have any information for, so we're just not going to put anything there. So I'm going to skip a for now because this should be the newest concept to you. I'm going to do the h and the k first. So x minus h, this is a left or right movement. So if you remember the x squared, the original point, starting point, is at 0, 0. And then our vertex here is 3, negative 4. So that means that h equals 3 and k is negative 4. So I'm going to bring all this all down. Here we have x, bring down that minus 2, 3 squared, and then we can write that as plus negative 4. That's the same thing as just minus 4. I'll rewrite it one more time. And then we haven't dealt with a yet. So this is what we have so far. And if you look at it, this means right 3, because that's the opposite of what it looks like. This is actually a positive 3, not a negative. We've just shown you that. And down 4. So if we go to that vertex, we'll move right 3 and down 4. This makes sense. Last thing we need to deal with is the A. What is the A? A is like slope. I want you to be very careful with this concept because, and I'll show you, it is not slope in what you're used to, how it just keeps going. This works for 1 point. So we're going to start at the vertex, and we're going to find the next point that this graph runs into. So if I go up 1 over 1, there's not a point there. So now let's go up 2 over 1. So notice when I go up 2 over 1, I do hit a point. That's my next solid point that the line goes through. So we went up 2 and over 1. So A equals 2. You just write 2. It's always going to be 2. You don't write 2 over 1. It's just 2. So I'm going to rewrite this one more time. A is 2, x minus 3 squared, and then I'll rewrite that as just minus 4. That is the full equation. Again, you have to be careful here. So let me follow this just to show you it doesn't work for all the points. If I go up 2 over 1 again, 1, 2 over 1, notice it's not there. It's here. So this slope is not a general slope. It works for 1 point, and that's the first point after your vertex. So here it was this one. Up 2 over 1, we found our A. That's how you find it. Not that much more to it than that. So again, I'm going to clarify. A is like slope. It behaves like slope, but it isn't slope. Just want to make sure we're on the same page there. Hopefully that's enough just to get you through the equations. Genuinely it is. 16. Again, first thing you need to ask yourself when you look at this graph is what kind of function am I looking at? Here we have that V shape. You should recognize that as absolute value. Meaning the original function is just y equals the absolute value of x. So that's where we start with. And then again, I'm going to set it up in this general form here. Y equals a times the absolute value of x minus h plus k. And then we need to fill in these letters. I'm always going to go with a last, just because it's the hardest one to look for. So, find our vertex. It's right here. Our vertex is 4, negative 1. So if I come over here, 4, negative 1, 4 is h, negative 1 is k. Now bring down the rest of it. So we have x minus 4 minus 1. A. Let's find A. So let's go up and over till we find the next solid point. So up 1 over 1, nope. And here's the unfortunate thing with these. There's not a one-size-fits-all approach for all of these functions. With absolute value, I've shown you before, this is a linear function. Meaning, if there's no a in front, it's going to go up 1 over 1 the whole way. We clearly see that doesn't happen. So the easiest thing to do is follow the line until it goes through the top right corner of a box. So let's do that. Nope, nope. Here's our next solid point after the vertex. So now we're going to follow this slope, and I say that very carefully. It's not actually slope. This one is up 2, and right 3. So, since it went up 2, right 3, A equals 2/3, rise over run. So y equals 2/3 times the absolute value of x minus 4 minus 1. And again, just to verify that these work, this is right 4, down 1. If we start at the original point, which was at the origin, and we go right 4, down 1, we do end up at our vertex. So this all works out. 2 more. Here we have another absolute value. Y equals the absolute value of x. There should be something immediately different about the graph when you look at it. Hopefully you notice that this looks upside down. When it looks upside down, that means we have reflected it. Upside down. So it has been reflected. And when we say reflection, that's when we mean that negative sign. So I'm going to set up my basic general equation. Y equals, since I know A is negative, I'm going to go ahead and put that negative in front of the A. Negative A, absolute value of x minus h plus k. Now let's find our missing numbers. Again, I'll do A last. I'm going to do h and k first. They are easier. My vertex right here is negative 3, negative 4. And again, h is negative 3 and k is negative 4. So let's plug these in. H is negative 3. K is negative 4. Now again, when you bring down the x minus, make sure you bring down both minuses, not just the h. And then here, we have negative. And for A, we're going to look for slope. Now this time, since it's upside down, we're still going to go down one and right one. So usually it would be up one, right one. This one we'll go down one, right one to still follow the line to see where it goes. Now notice the next point is down one, right one, where it should be. And I can follow it the whole way, and it keeps going. Just like the normal absolute value of x that has not been changed. This means A is just 1. If A is just 1, you don't have to write it. If you want to write it, that is perfectly fine. It is still correct. But this is an instance where I can just write negative in front, and we're all good. So I'm going to leave it as just negative. Only thing we need to do is simplify this middle part. We cannot have x minus negative 3. That looks weird. So y equals negative, absolute value. 2 negatives in a row make it positive, so we have x plus 3 minus 4. And that is my completed equation. One more. 18. This one you may not recognize at first, but it is this graph here. Kind of goes off to the side. This is the square root function. Y equals the square root of x. So I'm going to write out the general form here. Y equals, it's exactly where it's supposed to be. It's not upside down, so I know A is not negative. A times the square root of x minus h plus k. Let's find these letters. Our starting point here, technically still called our vertex, is 1, negative 3. So 1 is h and k is negative 3. So h is 1, k is negative 3. Bring down the rest of it. We have square root x minus, bring all that down. Only thing up for debate still is the a. So if a is just 1 and we don't have to write it, if we could go up 1 over 1, it would work. That did not work. So now I'm going to do this one just like I did with the parabola. Or you could do it just like I did with the absolute value. Just follow it till you hit a solid point. So where it goes to the top right corner of the box, right there. So this one is up 2, right 1. So in this case, it's 2 over 1. A is 2. And there is our completed equation. And just to verify that this works, just to show you, convince you, this is right 1, because we do the opposite, and down 3, which is exactly what our vertex is. So it works out. The big obstacle to jump over for me for this, and I'm sure for you guys as well, is this A value. Don't worry, we're going to practice with it quite a bit more, but it genuinely is not a huge deal on the test. So if by test day you are still struggling with it, I would not even worry. One more page. This is just to kind of sum everything up into just a nice little organizer that you can easily look at. And also, you could easily tear this off of the notes and then just have it to reference as well. That's completely up to you. So here's our very general form of any type of equation. F of x or y equals a times x minus h plus k. And hopefully you recognize this information by now, having gone through the notes. So again, this is just to put it all together in a way that is concise and easy to read. So if a is negative, that means that we have a reflection. So if we have a reflection, let's use this just with the quadratic, so the u. This would be before, and then after, it would be upside down. Reflection, before and after. If that's if a is negative. If a is, and this is right, is between 0 and 1, a is between 0 and 1. So for example, that would look like 1/2, 2/3, 3/4, anything like that. Then it is a compression. And so again, if we had, this would be like your before, and then after, it kind of flattens out. It looks like we're pressing the arms of the quadratic down further. Press down, compression. And then if a is bigger than 1, so for example, if we had 3, 5, 10, something like that, then we call this a stretch. So if we had our normal u, this would be before, and then after, definitely looks taller and skinnier. It looks like someone's taking their arms and stretching them upward. Two more. The H. This is a left or right movement. Left or right. H moves it left or right. Reminder, it's with the X. And on the X-axis, we move left or right. So that's how you can remember. So if this were left, for example, left 7, then we would have y equals x plus 7, because remember, we do the opposite. Left 7 is a negative movement. And when we put it in here with the x, we change the sign. So if you need to remember, we read that as a negative 7. And hopefully after doing these notes, you fully understand why the sign changes when we put it in there. That minus is going to shake things up. And if we have right, say we have right 3, then we would just have y equals x minus 3. And again, we interpret this as a plus 3. When we put that into our formula, that's going to change this positive 3 to a negative 3, visually speaking. But we still understand it's a positive 3, meaning we move it to the right. All right, K. K is the last letter. It's on the end if it's there. And this means up or down. And this one's much easier because you read it exactly as it says. So for example, we had up 2. Then this would look like y equals x plus 2. And for example, if we had down 5, so be y equals, and I'm going to drop the parentheses because a lot of times they don't even have it there. Let's just do x squared, for example. X squared minus 5. It'll look like something like that. And you read them exactly as it says. So this is kind of a nice go-to chart for you to look at as you're doing the other examples that I left for you to do on your own, as you're doing your homework, as you're studying for the test. This is something you can look at to help you remember all the different types of transformations we have for the class. that is all for this video. If you have any additional questions, feel free to reach out to me via email or when you see me in person. Otherwise, I hope you have an awesome day. Bye.